Hello guys, I am Alif.
Hello guys, I am Gitari Rahmia Putri.
Hello guys, my name is Irmala Syabani.
Hello guys, my name is Nusrina Wulanstiani and we are here to present to you the investment decisions and criteria of Mass Rapid Transit or MRT Jakarta as our case study. But before we jump into the case study, first we have to learn the basis of the investment decisions and criteria itself. Here to explain the investment decisions and criteria is Gitari Rahmia Putri.
So, in this occasion, we will talk about investment decisions and criteria that consists of 3 points. The first is discounting and indicators of viability, and the second is project alternatives, and the third is investment decisions. Before we start to talk about the 3 points, let me tell you about what is investment. What is investment? Investment is an allocation of resources for medium or long term than the expected effect to recover the investment cost and have a high profit. Besides of financial resources, material and human resources are used as well. The economic and financial environments influence the investment, so expected results are uncertain. The first point is about discounting and indicators of viability. In investment project analysis, after identifying and valuing project benefit and cost flows accrued in different years of a project's life that normally spans 20 or until 30 years, the future flows should be converted to their present values or the value of the base year by discounting at a required economic discount rate. The discounting allows calculating aggregate indicators of economic viability of a project for making investment decisions. There are 4 most commonly indicators that use to determine economic viability. The first is economic net present value or ENPV. The ENPV is the sum of the differences between the discounted benefit and cost flows. It can be estimated as the formula that you can see on the screen. And the second is economic internal rate return or IRR. The IRR is the discount rate at which the ENPV becomes zero, and it can be estimated from the following formula that you can see on the screen. And the third is benefit cost ratio. The BCR is the ratio of the sum of present value of the project benefit to the sum of the total project cost, and it can be estimated as the formula that you can see on the screen. And the last one is cost effectiveness ratio or the CER. CER is the ratio of the present value of a project's investment and operating cost to the present value of the project output or outcome, and it can be estimated from the following formula that you can see on the screen. And then the second point is project alternatives. Very often the several alternative project options achieve the same objective of an investment. The option can differ in technology, location, scale, or design, including the use of materials. Project options can also involve the different investment timing and include delaying a project as an alternative. Whenever possible or mutually exclusive, technically feasible alternatives option should be assessed and compared. And then we will talk about the third point as investment decisions. The investment decision relates to decision made by the investors of the top level management with respect to the amount of funds to be deployed in the investment opportunities. Investment decisions are made after a complete analysis of the investment project. So, this is the investment decision rules. As you can see on the screen, the investment projects such as power, transport, urban development, and rural irrigation generate economic benefits, most of which can be valued, and establishing economic viability requires a full cost-benefit analysis. However, for many social sector projects, some poverty targeting projects, and projects that primarily generate environment benefits, the conventional measure of economic benefits, such as willingness to pay, may not adequately capture their social value. Next.
Now we discuss alternative project in investment decision and criteria. Frequently, several alternative project options achieve the same investment objective. Options can differ in technology, location, scale, or design, including the use of materials. Next slide. For example, in urban traffic congestion can be overcome by improving the existing road network or building a new subway system. In this connection, traffic congestion in the metropolitan city of Jakarta has been very severe due to high population growth as a result of economic growth and population flows into provinces around Jakarta that are increasingly large. To be able to overcome the problem of traffic density and environmental degradation, the development of a rapid mass transportation system, which is stated by the MRT project, is one of the urgent project options for the city of Jakarta and the Indonesian government. Technology is often an important factor to consider in assessing project options. Some new or more advanced technologies might involve greater initial investment, but they have lower operating and maintenance costs compared to traditional ones. It is important to look at the cost and benefit when therefore choosing technology for a project. Next slide. However, the traffic charged by PT MRT Jakarta to passengers is not proportional to the operational and maintenance costs. The difference is more than double. Then how does the Jakarta MRT close their funding? While operational and maintenance costs can reach 500 billion rupiah per year. At present, what the DKI regional government is providing is subsidizing passengers' tickets. However, going forward, it does not rule out the possibility of the Jakarta MRT itself to finance its operational expenses from the potential transit-oriented development. In some cases, such as the MRT, current technology choices might have long-term implications outside the life of the project, making it very expensive to switch to alternative technologies. In such cases, the choice of technology must consider factors outside the life of the project in question. This usually requires broad sector assessment of long-term technology options rather than analyzing individual projects that are of benefit in the wider community. The benefit of having a mass transportation system is expected to reduce congestion that often occurs. In addition, the existence of the MRT is also expected to provide other indirect benefits, namely reducing pollution from motor vehicles and the use of fuels. Thus, the public can realize how important the existence of mass transportation facilities.
After we learn the basic of the investment decisions and criteria, we can now jump into the case study. The first topic that we will discuss in this case study is discounting and indicators of economic viability of MRT Jakarta. Now, as previously mentioned, the discounting allows calculating aggregated indicators of economic viability of a project for making investment decisions. Now, in the case of MRT Jakarta, according to Special Assistance for Project Implementation or SAPI Jakarta, MRT project will be financed by GICA or Japan International Cooperation Agency, in which they offer soft loan for build Jakarta MRT infrastructure with low interest of 0.4% and gives MRT infrastructure a loan tenure for up to 40 years. However, the MRT project should be fulfilling specific requirements provided by GICA, such as the national eligibility of prime project supplier should be from Japanese companies, and the project itself should apply Japanese technologies for up to 30%, as well as the need of GICA approval relating to procurement process. Next, we will be discussing about the basic financial assumption of MRT Jakarta project. In this part of discussion, we use the data from the study conducted by Surahman and Setiawan in 2016. According to the study, the basic financial assumption of MRT Jakarta project consists of project cost, demand passengers, tariff or rate, interest rate, inflation, concession operation period, and train operation planning. For the project cost, MRT project cost is estimated at 11,679 billion rupiah. As for the demand passengers, MRT project in its operation is predicted to carry around 280,000 passengers per day. For the tariff itself, the MRT project will charge a passenger for 15,000 rupiah per one trip. For the interest rates, MRT project consists of existing loan scheme by GICA with low interest of 0.4%. And for the inflation of MRT project is held at 10.24% and will be compounded yearly. As for the concession operation period, MRT Jakarta is predicted to last for a good amount of 30 years. And for the train operation planning, MRT project will have headways for estimated at around 5.5 minutes from one station to another station, and the scheduled speed and time for just one way is estimated around 27 km per hour and lasts for 31 minutes for one trip. For the operating distance, MRT railway will span for 13.725 kilometers with operating hour starts from 5 a.m. to 10 p.m. For the stopping time at one station, MRT Jakarta train is estimated to stop in one station for around 1 minute per station. For the passenger capacity of one car is estimated around 140 passengers per car. And as for the passenger capacity of one set of train, consists of 6 cars, is estimated around 1,512 passengers per train. Next, we will be discussing about capital expenditure assumptions and also revenue and operation expenditure assumptions. For the capital expenditure assumptions, as you may know, the Jakarta MRT is planned to be developed in 8 years and consisted of 2 phases. The first phase is the feasibility study, while the second phase is for the MRT construction and civil works. For the first phase, the feasibility studies are conducted comprehensively and follows by procuring and resettling the land, in which will take 3 years to do. While the second phase, the MRT construction and civil works includes the building of track, civil and electric work building, station works, and also depots and connecting ways, in which will take 5 years to build. As for the revenue and operation expenditure assumptions, the main revenue contribution for MRT Jakarta project came from the fare box revenue, in which the tariff is set for equal 15,000 rupiah per passenger for one trip. Meanwhile, the demand passenger of its operation is predicted to be 280,000 passengers per day. With the optimistic case, the number is predicted to be 15% higher, and the pessimistic case predicted that the number will be 20% lower. This passenger's target will be reached with the specific conditions that are mostly under control by the provincial government of DKI Jakarta. Meanwhile, on the cost side, the operation expenditure consists of direct costs and indirect costs. For the direct costs, it will consist of operation, energy, and maintenance costs, while the indirect costs consist of depreciation of infrastructures and also rolling stocks. It is said that the biggest expenditure is operation and maintenance, which was predicted to take at least 57.9% of the total cost. Next. And now, we finally reach our final discussion of the first topic. That is economic net present value or ENPV and economic internal rate of return or EIRR of MRT Jakarta. Based on the existing project cost structure with adjusted inflation and existing financing scheme provided by the SIPR study in the study conducted by Surahman and Setiawan in 2016, the financial feasibility resulted in strong results of EIRR at 11.74% and ENPV at 53,155.74 billion rupiah during the 30 years of operation period. As you may see in the table on my right side, the negative cash flow occurred during the preparation and construction phase, which reached the top at 6 years at 3,561 billion rupiah, an accumulative amount at 12,875 billion rupiah, with inflation adjusted. Furthermore, starting from commercial and operation date, cash flow began to become positive as the project starts to operate and receive revenue. The trend of the cash flow is increasing during the operational phase and attained break-even point in year 24 or in its 16 years of the project after it first commercialized. It means that the investment cost is fully recovered by MRT revenue after 16 years of its operation. Meanwhile, the IRR of 11.74% of existing ship should be at least the same as the risk-free 30 years government bond yield to make the bond interesting enough to attract investment to the market.
I will explain about investment decision and its correlation with our case study MRT Jakarta. Investment projects such as power, transportation, rural development, and irrigation generate economic benefit, most of which can be valued, and it requires a full cost benefit analysis. For some social projects, such as poverty targeting project, general economic measure of economic benefit analysis may not adequately value its social value. Investment decision rules under different situations are presented on the screen. You can see on the screen investment projects such as power, transportation, urban development, and rural irrigation benefit can be valued. Meanwhile, social projects such as poverty targeting project, its benefit either can be valued or cannot adequately valued. In our case, MRT Jakarta is investment project in transportation sector, so its economic benefit can be valued. But MRT Jakarta has an alternative project called LRT Jakarta. When it comes to this condition, we can calculate its benefit by involve two steps and presented on the screen.